Hello, I'm William Armour, and this is the teaching lab at London Metropolitan University. And today we're going to go through doing a full blood count on a haematology analyzer. And we're going to look at this analyzer here, which is the Horiba Pentra 60 analyzer, because it does 60 samples per hour. Basically, it's an enclosed system, and this is the sample port where you place the sample in, close the door, and the analyzer will aspirate some blood from your sample, and it will dilute the sample and mix, and it will count the cells and the hemoglobin. It will count cells using flow cytometry, and it will count measure the hemoglobin using spectrophotometry. If I just show you in the front here, you can see there are some reagents here. There is a cleaning solution and some dyes here to do the white blood cell count differential. This is eosinophics for the eosinophils and basolyse for basophils, and to lyse the red blood cells to do the hemoglobin concentration. Okay. This system is a small system, so it's mainly used for point of care testing, whereas a big laboratory would have a much bigger analyzer with a much higher throughput. But this is a good system for teaching purposes, and it gives students a chance to experience doing a full blood count on a haematology analyzer, getting the results and analysing the results. Okay, when you're doing any work in a laboratory, you should always wear personal protective equipment like a lab coat, gloves and eye protection. And each laboratory sample needs a unique laboratory number. When you do any test in a laboratory, you need to use controls and standards to make sure that the analyzer is giving you the correct results. And this is a control for this analyzer to make sure that the results it's giving us are the correct results, and we can be confident in issuing those results to a patient if we had to. Okay, so with every haematology analyzer, there will be a set of software which runs the analyzer and prints out the results. And we can see here, this is the results that you get from a full blood count. The red blood cells, the hemoglobin, the hematocrit or the packed cell volume, the mean cell volume, the size of the red blood cell, and the hematological indices, the mean cell hemoglobin and mean cell hemoglobin concentration. And we also have a red cell distribution width, which can highlight anisocytosis if it's wide. Okay? It also does a white blood cell count and a 5-cell differential. It measures neutrophils, lymphocytes, monocytes, eosinophils and basophils. And it also measures platelets. When it does the white blood cell differential, it gives a scatter plot, and each area represents a different cell type. Okay? When you're running samples on an analyzer, each sample must have a unique laboratory identification number, which is entered in here. So I'll just enter the identification number of this control, and then we'll run it on the analyzer. Okay, so now I'm going to run the sample through the analyzer. Always make sure any blood for full blood count is well mixed, because you need to make sure the cells are homogeneous throughout the actual sample. If you leave it standing, all the cells will settle to the bottom, and you may suck up an area of blood which has more plasma than it should, or more cells, depending on where the sample is taken from. Okay, the sample is placed in the sample holder on the front of the machine, and the door is closed, and it automatically samples the blood sample. It's a very safe machine, fully enclosed, because to sample the blood it has to pierce the cap, so a needle goes through, and there's no way that you can be injured. And once it's sampled, the blood is returned, so you can remove it, ready to load your next sample. The blood is sucked up into the machine, diluted in various ports, and the white cell counts are done, the red blood cell counts done, and hemoglobin is measured. The results have just flashed up on the screen, and it should print out a copy of the results on the printer. So what we can do with this control is we can check to see if the values that the machine is giving us correspond to the values that we should be getting from the manufacturer's results. And if we have a look, the red blood cell count should be 4.55 and 4.39, which is well within the range. The hemoglobin is quoted as 13.3. It's given us 13.2, which is acceptable within the range. The hematocrit as 48.6. It should be 39.1, so that may be slightly high. Mean cell volume is slightly high. If we look at platelets, 335 is the result given by the analyzer, and the value quoted is 255. Now we know that this sample is an old sample. It's been used quite a few times, so we would expect this sort of deterioration to take place. But if you got these results from a standard which was in date, you would reject these results and you would not use this analyzer until you got the correct results for the control. Okay, now we've run the control, we can run a sample. You must check the patient's details on the front of the sample to make sure they're all correct, and you need to enter the unique laboratory number into the computer. So I'll enter the number, and then we place the sample in the analyzer, close the door, and the analyzer will aspirate some blood and dilute it and count the cells. And the sample is aspirated, so it's returned the sample to us. This can be put wherever you keep your samples. The analyzer has just given us the results from the sample we've just analysed, and if we have a look, the white blood cell count is 8.0. The differential seems a bit strange. The neutrophils are only 16%, whereas the lymphocytes are 77%. Now I know that this sample is an old sample, so these results are not reliable. But this is just purely for illustrative purposes only. But if this was a true clinical sample, a neutropenia with a lymphocytosis could suggest a viral infection, or maybe the early beginnings of a leukemia, something like that. So you would have to look at a blood film to look at the type of lymphocyte. Are they reactive lymphocytes, for example, that you would see in infectious mononucleosis? So that's the white blood cell count. Neutropenia can lead to propensity to bacterial infection. So we'd have to find out the clinical history of this patient to see if these results were what was expected. The red blood cell count is normal, 4.63. Hemoglobin 15.2 is normal. The hematocrit is 46.4, which is normal. The mean cell volume is slightly high at 100. So that's a macrocytic red blood cells. So that could be suggestive of pernicious anemia. So we'd have to look again at the blood film to confirm these results and to see if they tallied with the patient's clinical condition. Platelets are 136, which is slightly low. Normal range is about 140 to 400, but that could be because the sample is old. Okay, so we've run through doing a full blood count on this ABX Pentra analyzer, and the main things to remember are to ensure when you're doing any laboratory procedure you wear the correct personal protective equipment. Make sure your analyzer is calibrated and you run controls to make sure it's giving you the correct results that you want, to ensure that the results you issue for patient samples are correct and you can have confidence in issuing those results. And obviously store your samples properly after you've analysed them.